Hi, today I'm going to present of my 5 minutes thesis presentation for my final year project assignment. So for my final year project title is Biopolymeric Nanospheres Synthesis for Selective and Reversible Absorption of Virus. My name is Shami Rashad bin Saiful with a metric number A17MJ0232. My supervisor is Dr. Kamya Shamili. So, as the introduction, the nano world is omnipresent in our modern societies, whether in optoelectronics and telecommunications, energy storage, sensors, transport, pollution control, biomedical science, and other domains. Nano objects surround us. In link with the human body, it is not surprising that nanotechnology should play a determining role in biomedicine, especially taking into account that most biologically relevant molecules are smaller than 10 nanometer and thus belong to this nano world. Also, another significant feature of nano objects is their capacity to exhibit enhance or new properties in comparison to their microscopic counterparts due to their high surface to volume ratios. In this context, nanotechnologies can prove helpful for the handling of virus infection via several aspects. Nanosystems can find application for virus detection and the setup of diagnostic tests for the separation or isolation of viral particles for playing the role of adjuvants in vaccine formulations and also as nanocarriers of active agents in non-vaccine approach. Finally, some nano-objects can exhibit by themselves a direct antiviral activity. So next slide is the type of biopolymer that will be used in my project. It contains chitosan membrane, genipin, and glycidyl trimethyl ammonium chloride, GTMAC. TPP crosslinker will be used instead of genipin due to genipin is too expensive in the market. So next, biopolymers are classified into different ways based on different scales. Based on their degradability, biopolymers can be divided into two broad groups, namely biodegradable and non-biodegradable, and alternatively into bio-based and non-bio-based biopolymers, as shown in the slide. On the basis of their polymer backbone, biopolymers can be classified roughly into the following groups: polyesters, polysaccharides, polycarbonates, polyamides, and vinyl polymers. These groups are again classified into several subgroups based on their origin. Biopolymers can be classified depending on the nature of the repeating unit they are made of into three groups. The first one, polysaccharides. Polysaccharides are made of sugars, such as cellulose found in plants. The second one is proteins are made of amino acids. As an example, myoglobin found in muscle tissues. And the third one is nucleic acids are made of nucleotides, DNA, genetic material of a given organism. Based on application, biopolymers can be classified as bioplastic, biosurfactant, biodetergent, bioadhesive, bioflocculant, and so on. So next, we will proceed to chitosan TPP GTMAC. So for the chitosan membrane, chitosan is the deacetylate derivative of chitin. It's a cationic polysaccharide that can form polyelectrolyte complex with other polysaccharides and is the second most abundant natural biopolymer after cellulose. It can be easily found in the shells of crustaceans such as lobsters, crabs, and shrimp, and many other organisms, including insects and fungi. It consists of beta-1 to 4-link D-glucosamine and N-acetyl D-glucosamine due to easy applicability, water solubility, oxygen permeability, blood coagulating property, and cytokine induction, which activate the fibroblast migration and proliferation. It is used as wound dressing material. So next, we will proceed to tripolyphosphate (TPP). Cross-linking reactions are required to modify the functional groups on chitosan and to increase the number of active groups of chitosan. Ionotropic gelation of chitosan by polyanions, particularly by tripolyphosphate TPP, a non-toxic polyanion that can interact with chitosan via electrostatic force to form ionic crosslink networks, has been widely used. Ionically cross-linked chitosan hydrogels can be used as drug delivery system for control release not only in acidic but also in basic media for rapid release by dissolutions and as thermogelling system. So as you can see in the slide, the left hand side of the slide is the chitosan and the right hand side is tripolyphosphate TPP. So the last one is glycidyl trimethyl ammonium chloride GTMAC. This is the synthesization of chitosan with GTMAC to form 2-hydroxyl propyl 3-trimethyl ammonium chitosan chloride, abbreviated as HTCC. So the left, as you can see, the left hand side is chitosan react with GTMAC and produce HTCC, hydroxyl propyl trimethyl ammonium chitosan chloride. So as the mechanism, the desorption of virus involves sodium chloride is sodium chloride. Uh, so so the virus will be absorbed through the active site of the GTMAC, and the absorption the HTCC will be cleaned by the sodium chloride. So that's all from me. Thank you.